Hello and welcome to this overview of new features in the FVA-Workbench version 6.0. My name is Gary Bratton. I'm a technical writer at FVA, and it's my pleasure to be your host today. Keep an eye on the FVA website and YouTube channel for more information, and feel free to contact us with any questions at info@fva-service.de. I'd like to start with a few words about the FVA Workbench. The FVA Workbench is a vehicle for the practical application of FVA research knowledge. The FVA Research Network consists of 50 institutes with 25 working groups of top experts and is able to promote 200 projects and studies per year. The research knowledge generated in these projects then flows into the FVA Workbench. So the FVA Workbench is a ready-to-use software solution for the application of research knowledge from the FVA network. A quick look at what we'll be talking about today. We'll start with some new interface features, move into calculation updates, starting with cylindrical gears, and then system calculations, and then updates to bevel gear calculations, and then we'll talk about some new calculations in version 6.0. Starting with some simple but helpful enhancements to the editor. Now you can do simple calculations directly in the input field in the editor. So you can use basic operations, addition, subtraction, multiplication, and division, and the FVA Workbench will determine the result, as you can see here in the position field. Another often requested new feature is helpful error messages. So any missing parameters are detected, and error messages now include links to the associated input field. So you can right-click on an error message in the Messages window and choose Go To, and you'll be taken automatically to the right place in the editor where you can make changes to your entries. We've also added a component search feature. So messages always include the relevant component, both the name and the ID. However, for large or complex models, it's not easy to find the right component, and therefore we've added a search feature in the model tree to help. So as you can see at the top here, there's a new magnifying glass. You click on that, and the search field will come down, and then you can specify what you're looking for, and that will help you to locate it in the model tree. Another area where there have been some major changes is the report manager. So common feedback that we received from users is that it was very difficult to compare reports. And so we have been able to implement some new features to make that possible. So the report manager no longer saves reports, it now saves results, allowing you to make changes to models, run calculations, name reports, and compare results. And we'll see a demo of that later. But here's a preview of what it looks like. You see the two reports next to each other, and anytime there are differences in the two reports, those will be highlighted in yellow. So this makes it very easy to make changes to your model, such as the bearing arrangements, the geometry, calculations of different standards, etc., and compare the differences, immediately seeing all the effects side by side with differences highlighted. Moving on to the calculations. The biggest changes have been in the cylindrical gear geometry calculations, which have been completely re-implemented based on DIN 3960 and ISO 21771-2014. So common feedback from our working group was that they weren't very satisfied with gear geometry calculations in previous versions of the Workbench. They were slow and didn't provide enough information. So again, we have now completely re-implemented the gear geometry calculations, and that has been modularized. It's faster. It offers better visualization and output options, as well as some new export options. We've also been able to integrate some simplified troubleshooting. For example, for meshing interference, the tip profile of the mating gear indicates where meshing interference occurs, and this is shown in the graphics of the Workbench. As you can see here in the image on the right, you can see that there is no meshing interference in this model. Also for the gear geometry, the messages indicate what is triggering the issue, and there are numerous checks to support the entry process. As mentioned, the gear geometry calculations are also much faster in the new version. So previously with ST Plus, calculations could last 1.5 seconds and be up to 25% of a system calculation time. We've been able to reduce that in the new version to 1.5 seconds for the first calculation, and any subsequent calculations that build on those calculations can be even faster. Another new development is that the geometry is always calculated for the entire system, and so the button to perform that calculation has been removed, as it's no longer necessary. Updated export options in the gear geometry calculation include representation of the tooth mesh in reports, and both the individual gears, including exact tooth root fillet, and complete gearboxes can be exported in CAD format, and this data is also available to the scripting engine and can be exported in Excel or CSV format. Here's a preview of the updated output. So as you can see, very graphical, very interactive, and there is also some new features available, such as the tooth engagement analysis of meshing interference as shown in the bottom right. As you're surely aware, there's a new version of ISO 6336 released in December of 2019, and that has of course been integrated into the new version of the Workbench, enabling you to continue making calculations according to the current state of technology. The differences between version 2006 and version 2019 were documented in FVA 814, and this is also a perfect opportunity for comparing reports to see the differences between 2016 and 2019, which we will do in a few moments. Another FVA research project that has been integrated into version 6 of the Workbench is the functional closed loop. So the goal here was to reduce scrap and rejects. So for example, borderline cases for production that are outside of the geometry tolerances, but with the right combination may still be within the functional tolerances. So the idea is first consideration of the exact manufactured geometry, determination of pairings to compensate for any negative effects, and recalculation and mathematical validation of limiting cases. The implementation includes import of GDE measurement data and selection of the data to be included. So that's a new feature that we'll see as well. So how is it done? We start by calculating the optimal parameters, importing measurement data, and then comparing it to each other. So now I'd like to jump into the Workbench and give you a chance to see what some of these new features look like in the system itself. So here I have a brand new model. I'll start by adding a component, cylindrical stage. And you'll see here I can enter my data for both gears. What's new here is that I can choose either a new gear or a gear from a GDE file. Select the file and choose Open. And you'll see that the gear information is updated here. I'm actually going to go back to a new gear, make some changes to gear 1 to make it more similar to gear 2. So I'll change the face width to 36, change the position of both gears, select a material for both gears, and we're good to go. So you can see visualization of the gear here. I'll double click on that. And a new feature is that you can right click and choose Show Fine Geometry. And when that's done, you can see that the geometry is now shown in much greater and more accurate detail. I'll minimize that and run some calculations as well. So we'll go back to our cylindrical stage. The available calculations are shown here below. We'll start with gear geometry, select the main geometry, and choose Run Calculation. A new feature is that it will ask you to enter a name for the model snapshot. I'll just go with the default here. Click OK, and you can see that that shows up in our list of model snapshots. You can, of course, load report templates. I'll choose a cylindrical stage template here, geometry of cylindrical gears. Select that template, go back down to my model snapshot, and choose Generate Report. You'll see it open my web browser, and you have your report available. All of the information at the top, and then as you scroll down, you'll also get to the graphical content, such as tooth contact. You can see an animation of that, as well as the tooth engagement analysis, specific sliding, etc. And again, these are all interactive. You can run some additional calculations here as well. So I'll go back to my model. We'll go to the gear unit, add a speed and direction here, choose 3000 clockwise, add a couple of loads as well, specifying the amount of power. We'll choose 80 kilowatts and the position. Okay, so I'll go back to my cylindrical stage here, and we have our gear geometry calculations. We also have gear load capacity. As I expand that, you'll see that we have ISO 6336 versions 2006 and 2019. Start by selecting 2006. Click Run the calculation. I'll be prompted to enter a name. Again, I'll just choose the default here. Click OK. And the calculation fails. So as you can see, the new feature you can choose here, go down to your messages, the error messages, right-click on the message, and choose Go To. That will take you to the appropriate location in the editor where you can enter missing information. So we'll choose a lubricant first, then right-click on the second error message. We'll change our calculation method for the face load factor of the flank. We will specify 1.2 here, and then we'll run the calculation again. This time I am going to give it a name. I'll call it ISO 6336 2006. We'll see that show up in the list of model snapshots. Then I'll select 6336 from 2019, run the calculation again. Give this one the right name as well. So we see our two model snapshots here. I'm going to choose a different report template here for system calculations. And then I can compare these two reports. The way you do that is to start by selecting one as the reference. So right-click on it, choose Set as Reference, and then go to the other snapshot that you want to compare. Right-click on that one and choose Compare with Reference. Again, you'll see it open my web browser and then generate the report. You can see here on the left, we have the ISO 6336 2019 report, and on the right, we have the 2006 report. So you have the two reports side by side, and as you scroll through the report, anytime there are differences in the two reports, you'll see those highlighted in yellow. So very helpful feature here. So now I'll go back into my presentation, continue looking at some of the new features, starting with the influence of centrifugal force. So we had a frequent question from users of how the centrifugal force is calculated in the workbench. And the answer is that it's calculated as a point mass, but after in-depth investigations, we have determined that that is not a safe assumption. So the amount of error from this point mass assumption depends on the ratio of the center distance to the planet diameter, but can be off by as much as 6%. for common sizes. So we've now added a correction factor in the new version of the Workbench to compensate for this error and allow for more precise calculations. Displacement due to centrifugal force can lead to rear flank contact, and rear flank contact is also detected and reported in the new version of the Workbench. So rear flank contact can occur with insufficient backlash. This is for gears with low clearance, with very large deflection of the teeth in mesh, from centrifugal force, and also from the load-dependent center distance, which is another new feature in version 6.0. This was initially presented at the 2019 AGMA Fall Technical Meeting with a very extreme example. The example that we have today is not quite as extreme, but still shows what the differences can be. So there is an option in version 6.0 to calculate using the nominal center distance or the load-dependent center distance for load capacity calculations. So this can have a significant influence for long, thin shafts with flexible bearing arrangements, soft bearing support, flexible casings, or gears with root relief. And on the next slide here, we can see the results. So we have side-by-side results of calculations using the nominal center distance and using the load-dependent center distance. And we can see here for pressure distribution that the maximum Hertzian stress is greater using the load-dependent center distance. And underneath, for the 3D transmission error, we also see that the fluctuation ranges are greater using the load-dependent center distance compared to the nominal center distance. Another new feature in version 6.0 is load spectra for all gears. So the new damage calculation in load spectra can calculate the damage for all gears. Previously, this could only be done for one shifting position, and then those had to be manually superimposed if you had multiple gears. In version 6.0, the load spectra can be specified for each shifting state with a timeshare. And those can be directly considered in ISO 6336, bearing service life, and shaft load carrying capacity calculations. So we'll jump back into the Workbench to see a demo of these new features as well. So I have a model loaded here that's a little more complex. We have two shifting positions. Also, I can go into my calculations here. You'll see that I have Consider Load Spectrum selected. You can also see that I have it loaded. Going to the Power Flow tab, you can see that I've set up a timeshare of 30 to 70. So you can then go into the System Calculations and choose Run Calculation. I've already run this calculation in the background because it can take a little while. So when that's done, you'll see the model snapshot, and then again you can select a report template and choose Generate Report. I've done that already as well. So we'll jump in and have a look at what that report looks like. So we see our gearbox image here, and then you can also see that for each of the shifting states, those are included in the report here. And then you can scroll through and see the relevant information for all of the different gears. Okay, so back to the presentation. We'll move on to a word about meshing quality. So information that was available from the recent feature for calculation of FE wheel bodies included what percentage of elements do not meet quality criteria, which can lead to meshing problems for casings, planet carriers, etc. So we've now included that in the Workbench as a warning message, which can be very helpful for evaluating the meshing quality. So for example, what we see on this slide looks good. However, as we can see from the warning message, the meshing quality is actually not sufficient, which can lead to distorted elements. Moving on to the next slide, we see what it looks like with increased meshing quality. What previously would have been thought to be too fine, we can now see actually is required for added quality, adequate quality. As we can see here again, now a negligible amount of the elements do not meet the meshing criteria. Another new feature in version 6.0 is the pre-dimensioning of bevel gears. So feedback from users is that the standard KGD file, which is needed for bevel gear calculations, requires a lot of information that has to come from other sources. So what we've done for version 6.0 is added a pre-dimensioning of bevel gears feature based on ISO 23509, which allows you to create the abbreviated standard KGD file, specification of the main geometry, which can then be edited and recalculated in BCal as necessary. Moving on now to new component types in version 6.0. A new component type includes the spline gears. So you can calculate spline gear geometry according to DIN 5480. You can also calculate spline gear load carrying capacity according to DIN 5466 in the new version of the Workbench. These are relatively simple calculations, standard calculations at this point. However, we do have additional know-how from other projects that can be integrated, and this is planned for future releases. And finally, we have another new feature for the design of lubrication line systems and development of lubricant networks. So, a method for designing hydraulic networks was developed in FVA Project 8041. This was a study of hydraulic components in a climate chamber with different viscosities, and this has been implemented in version 6.0 of the Workbench as a lubricant distribution system. So you have your individual components, the pumps, lines, nozzles, etc. You can now determine the volume flow and pressure for each component to ensure that they get the sufficient volume flow. So this concludes our overview of new features in version 6.0. We think it's the best FVA Workbench ever. We hope you'll agree. We hope you find this a useful tool and that you're able to take advantage of these new features. If you're not yet an FVA Workbench user, you can request a free trial version at fva-service.de. And as always, we welcome any feedback on this tutorial, the software, any questions you may have, etc. at info@fva-service.de. Again, keep an eye out on the FVA Service website and here at the FVA YouTube site for additional content. Thank you for your time and attention.